Hello and welcome to another video. In this video we're going to be working on height checker, and in this one you have a school trying to take an annual photos of all the students. The students are asked to stand in a single file line in non-decreasing order by height. Let this ordering be represented by the integer array expected or expected I is expected height, and you're given the integer array heights representing the current order that the students are standing in. Each of the heights is 0 index. Return the number of indices where the height is not what it's expected. So basically you can see in these pictures, so you have your heights and then you have your expected order, and the expected order is just a sorted array. And then for every index you just check like, are they the same or not? So these are not, so that's 1 difference, 2 difference, 3 difference, so you have 3. And the second one you have all of them are different, so 5, and then the third one you have 0. So the basic problem is just like sort this array and then look for differences. And there's a bunch of ways you could do this, so I'll kind of show you one that people usually don't use, and it's going to depend heavily on your constraints. So it's good when the number of items you have aren't too different. So for example, if this heights I could be anywhere from like 1 to 10 to the 9th, let's say, this wouldn't be good. But because the heights are only 1 to 100, and this is 1 to 100, then this is like a reasonable solution. And basically the time complexity of this kind of sort is going to be O of n plus k, where k is like the number of values you can have. So you'd rather have n log n if this was 100 and this was like really big, but if they're about the same, then this is fine, because this is going to be better than n log n. Like let's say they were like 10,000 each or something, this would be better. And essentially it's called a counting sort, and basically what you do is instead of actually sorting, you just maintain the count of all your items, and you need your keys in ascending order, right? So you basically need to have a hash map, but you have to have your keys in ascending order. And if you just make a normal hash map, you can't do that. So instead, what we can actually do is we can just take an array. So we know like let's do an easier example. Let's say heights can only be 0 to 10, right? And they actually can in this case. So we can just make an array like this, and then for every height, we will just increase these values. So for example, let's go through this. So here we have height of 1, so we'll say we have 1 here. Then we have another height of 1. I guess we can just count it up totally beforehand. So we could say like we have 3 1s. We have 1 2, 1 3, 1 4. And we don't really know where these are. Like this can be anywhere at the end. Like we're basically going to have this 1 through 100, and our heights can be anywhere. So we're going to have to go through this whole thing. So we don't really know where they are, but we can go through them in sorted order because we know, okay, so we know that like 1 comes before 2, comes before 3, comes before 4, and so on. So we can just go through this whole array, right? We can just go through this whole array, and we can just keep going until we get every number. And they're going to be in increasing order, right? So we know we have 3 1s, 1 2, 1 3, 1 4. And we can basically compare this now to the original heights array. So if we take the original heights array, and we put in our numbers, so we have 1 1 4 2 1 3. We could say like, okay, well the first 3 numbers need to be a 1. So let's check the first 3 numbers. We have a 1, we have a 1, and we have a 4. So we have 1 mismatch here, so that's 1. Then the next number needs to be a 1. And so we can use 2 pointers to accomplish this, right? So we can have a pointer here, a pointer here. So we can say, okay, this next number needs to be a 1. Or sorry, it needs to be a 2. And it is a 2. Then the next number we find needs to be a 3, but it's a 1, so we have another mismatch. And then the next number needs to be a 4, and it's a 3, so we have another mismatch. So we have 3 total mismatches. And that's kind of the idea. So if you want to make this array as small as possible, we can go through our original array first and get the maximum. And then once we get the maximum, then we can make our array that size. Because, or technically I guess we can get the maximum and minimum if we really want to be like super efficient. Or we can just make an array of length 100. Either one is fine. So I guess what we can do is for our heights, we will go through and get the maximum, and then we'll make an array of length that. Then we'll get the count, and then we'll just use these 2 pointers. We're going to go through our heights, and we're going to go through our numbers, and we're going to just check, like, whatever number we need, do we have it? And we don't notice we don't need to sort anything because we have a brute force count. But this will be really bad if heights would be like anywhere from 1 to 10 to the 9th, because then like imagine your numbers are like 1, like imagine this is pretty small, and you have like 2 3 4 10 to the 9th. Now what's going to happen here is in this array, you're going to have to start from here, and you're going to have to go all the way to 10 to the 9th because you don't know, like some of these are empty, and the ones that are empty, you just have to keep going to the next one. So you're kind of like brute force checking, like, is this number there? If not, go to the next one. If it is, then let's check if it's the same thing here. So hopefully that makes sense why that's the case. So this is really big. Don't use this if this is really small. Like imagine if this was 10 and this array was, you know, 1,000,000, then this would be very, very, very good. So hopefully that makes sense, like when you'd want to use it now. So essentially we can do one of two things. We can either just make an array of length 100, or we can take the maximum of height. So let's just take the maximum of height. So we can say like int max equals 0. I think max is probably some special thing, maximum or something. Okay, and we can just go through our numbers and heights. There might be some built-in function. I don't know it off the top of my head though, so heights. Equals. And I don't think math max takes an array. I think it takes 2 numbers. So, okay, and this is just going to be... Okay, now that we have that, we have the dimension of our counts array that we want. So we can say int array counts equals new int array. And to keep it easy, we'll just make it length maximum plus 1. So then we can just include every number will be its exact index. So this can be maximum plus 1. Because like let's say the biggest number is 10, then we want our array to have 0 to 10. I don't think we ever have a height of 0, but it's gonna make it easier so we don't have to like change indexing or anything. Okay, now we just have our result. And we have 2 pointers. So one pointer is gonna be for heights and the other pointer is gonna be for counts. So maybe we can say like int h equals 0 and c equals 0. And we'll say while h is less than height's length. So if one of them is out of bounds, then we're done. So we can say, or c is less than counts length. Okay. Now, basically, so like I said, in this array, we can technically have values that don't exist, right? Because like, let's say we have a 1, but we don't have any of these. So if we're on a value that we have 0 of, we just want to go to the next number. So we can say if counts c equals 0, let's just increase it and move on. Okay, we're always going to be on a valid height. Like we're never going to have like empty things for there. So now we just basically need to check. Now we're guaranteed to be on a count that's non-zero, and then we just need to check is the height equal to that. So we could say if height, and then the value is going to be count c. Actually no, the value is going to be h does not equal. So actually the value is not going to be count c. Remember, count is the count of the number, but the actual index is the number we're looking for. So it's just going to be the index. So if height h doesn't equal c, then we don't have the right number, so we can just add to the result. And either way, we are going to increment height here. And we're only going to increment, oh, and then we also, so we're going to increment height. We're not going to increment count, but we are going to decrease the value. So if we're on some value that has a count of 2, now that like we checked if it's 1, we need to decrease the value. So we're going to say here, counts c minus minus. We're going to keep decreasing the value to check if it's the number. And then when it's 0, then it will just go to this case and go to the next thing. And yeah, it should be it. So now we'll just return result. Let's see, heights. Let's take a look. What error we have here? So index out of bounds. So this needs to be and actually. If one of these is not the case, then we're done. Okay, looks like we have an error. Okay. So let's see what we did wrong. Yeah, so it looks like we have 0. Do we have 0 for all of them? Yeah, we do. Okay. Did we ever actually take a count? Oh, that's what we missed. So for counts, we never actually got the count. So we have to go through this guy again and get the counts. So counts num plus plus. There we go. Now it should be good. Okay, there we go. All right. And yeah, so this is not going to be n log n. This is going to be n plus k, where k is the total of numbers like this guy, which will be faster than n log n for 100, because 100 log 100 is obviously longer than 100 plus 100. I'm in space. So we did make the counts array, which is just going to be based on this, so I'll just call that k. Yeah. And if you don't want to do it this way, you can obviously use a built-in sort. That would be the easiest. I think this still runs faster. Or if you want to practice your other sorts, I'd probably recommend, and the one that I use mostly is merge sort. I think that's like the most common one, so you could practice merge sort, or I think that's honestly the only one that I remember off the top of my head that's efficient. There's like bubble sort and stuff, and I know that one, but that's like worse time complexity. I think the other good one is like quicksort and heap sort. I could probably do heap sort. I don't remember exactly how quicksort works, but you can like double check it and try that as well. But yeah, that's going to be all for this one. Hopefully you like it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.